The universe is silent, and that silence is terrifying. But what if it's not a warning? What if it's a birthright? I'm going to reveal three things this video: the 3 billion-year gap where nothing should have been possible, the genetic bottleneck that almost erased us, and the magnetic secret that kept our air from being ripped away. By the end, you'll understand why we might be the loneliest, luckiest species to ever exist. You've probably heard the Fermi paradox. Our galaxy should be crawling with aliens. So where are they? Most people point to the Great Filter, some barrier that wipes out life before it reaches the stars. And here's the cozy myth: we've already passed it. We think our technology proves we're survivors. But what if that logic is dangerously inverted? What if the filter is a cascade of cosmic traps, and we only understand the ones behind us because we're still here to tell the tale? Let's detonate the myth right now. Most people believe the Great Filter is definitely behind us because we're alive. Even some scientists assume it. But a 2002 analysis by Nick Bostrom in the Journal of Evolution and Technology showed something chilling. It's the observer selection effect. You can only observe a planet that survived up to this point. That doesn't tell you what's ahead. Think about it. If 99% of civilizations nuke themselves after inventing the internet, you'd never know it until you're the one holding the button. The filter could be in our future, and we'd be barreling toward it blind. But to truly grasp where the filter lies, we need to rewind. Way back, 4.5 billion years ago, a Mars-sized planet slammed into the proto-Earth, Theia. That impact almost vaporized us. Instead, it created our moon. And that moon gave us tides, stabilized our axis, kept our magnetic dynamo spinning. Without that collision, no complex life. So here's the first whispering question: was that just a random lucky punch? Or the first door of a cosmic obstacle course that sterilizes almost every other rock? Now jump forward 500 million years. Life appeared, fast, almost as if the universe was eager. But then, silence. For over 2 billion years, nothing more complex than a single cell. 2 billion years of stagnation. Why? The leap from simple prokaryote to complex eukaryote requires a freak merger event, a bacterium swallowed by another, becoming mitochondria. The probability of that happening. A 2007 model in biology direct pegged abiogenesis alone at 1 in 1041. That's a 1 followed by 41 zeros. Listen, the real filter might not be the start of life. It's the endless, aching wait for complexity that never arrives on most worlds. Then came the oxygen. 2.4 billion years ago, cyanobacteria started pumping out O2. It was a poison. Oxygen wiped out almost every anaerobic organism. Life was nearly its own filter. But that same poison enabled the metabolism that would one day power brains. A 2014 study in Nature called the Great Oxidation Event the single most dramatic environmental shift in Earth's history. Here's the terrifying implication. On another world, a similar event might permanently sterilize the atmosphere. A double-faced filter. We got the latter. Still, it took another billion years for anything truly complex to emerge. In fact, the Cambrian explosion 540 million years ago was a one-time ignition. Almost all modern animal body plans appeared in a geological heartbeat. Paleontologists like Andrew Knoll, in his book, Life on a Young Planet, point out that there are no repeats in the fossil record. No second Cambrian. What if that burst of diversity was the hardest step of all? A genomic accident that requires such precise conditions that it simply never happens elsewhere. Now listen, all of that is useless if the planet isn't shielded. Earth's magnetic field has been active for at least 4.2 billion years, according to a 2015 study in Science using single zircon crystals. This shield deflects the solar wind, preventing our atmosphere and water from being stripped away. Most Earth-like exoplanets, however, lose their magnetic dynamo within a billion years. Without it, they become Mars, dry, dead. So here's another filter. A long-lived magnetic heart is staggeringly rare, and we have it. But wait, there's more. In their landmark book, Rare Earth, Peter Ward and Donald Brownlee argued that complex life also needs a large moon, plate tectonics, and a Jupiter-like guardian to clear out most impact threats. Our solar system has all three. That combination could be astronomically unique. According to their analysis, the odds of a planet having this trifecta are vanishingly small. If they're right, we aren't just rare. We might be the only thinking beings in the entire galaxy. And that brings us to the next cold truth. The asteroid that killed the dinosaurs 66 million years ago wasn't just a catastrophe. It was a filter that cleared the stage for mammals. The 2010 Chicxulub impact study in Science confirmed the exact timing. Without that random rock, T-Rex might still be here, and we might never have evolved. Think about it. The filter can wear the mask of an extinction event, but if you're the lucky recipient of the aftermath, it's an opportunity. A ladder, not just a wall. Now we've talked about deep time, but the filter can be terrifyingly recent. Around 70,000 years ago, the Toba supervolcano erupted in Indonesia. Genetic evidence published in the Journal of Human Evolution shows our species was reduced to perhaps 10,000 breeding individuals. We almost vanished. One more volcanic winter, one failed monsoon, and Homo sapiens would be a fossil footnote. That was a filter we squeezed through by the skin of our teeth. And here's the paranoid thought. We might not even recognize the next one. Isn't it strange that we've catalogued over 5,500 exoplanets, yet not a single definitive biosignature, no simultaneous oxygen and methane? NASA's Exoplanet Archive confirms it. You might think we just haven't looked hard enough. And that's partly true. We'll get to SETI's haystack in a moment. But the silence is statistically loud. If life were common, we'd expect some hint by now. The emptiness of the cosmos is starting to feel less like a mystery, and more like an answer. Speaking of answers, let's tackle the second myth. We've listened for alien signals and heard nothing, so they don't exist. That's like scooping one glass of water from the ocean and concluding there are no fish. Jill Tarter, the legendary SETI pioneer, pointed out in her 2001 annual review paper that we've scanned only about 10 of the cosmic haystack frequencies, directions, signal types. 1/10,000,000th of 1 billionth. The silence may be our own listening failure. But let's go deeper. What if civilizations don't build Dyson swarms? A 2014 survey of 100,000 galaxies by Wright et al., published in the Astrophysical Journal, found no excess waste heat, no megastructures, no galaxy-spanning empires. That's chilling. Either intelligent life never expands beyond its home system, or something stops it, something that keeps the universe looking dead. And that brings us to the most terrifying filter candidate, intelligence itself. Before we dive into that, I want to ask you something. The comment section question for today is this: if you could know for certain whether the great filter is ahead of us or behind us, would you want to find out? Why or why not? Drop your answer below. I read every one. Now, let's look at why our own survival record might be the most compelling clue we have. We've survived nuclear saber-rattling for over 50 years. Declassified accounts from Stanford's CISAC and a 2023 study in Nature Physics reveal at least 5 near-miss incidents between 1962 and 1995 that nearly triggered global nuclear war by accident. 5 times. Each one hinged on a single officer's gut feeling, a tired sensor operator, a faulty radar echo. That's the filter right there, and we slipped past it repeatedly. But does that mean we're resilient, or just playing Russian roulette with the universe's deadliest toy? Isn't it strange that we've held the power to annihilate ourselves for decades, and haven't? You'd think some civilization somewhere would have pressed the button, but the galaxy is silent. So either we're the exception, or there's an even more insidious filter at work, something that doesn't come with a mushroom cloud, a slow, creeping collapse. That brings us to the third and darkest myth. The great filter solves the Fermi paradox definitively. It doesn't. In his 2018 book, Milan Cirkovic outlines half a dozen other hypotheses. The zoo hypothesis, post-biological ascension, phase transition theory. We just don't know.